All right, good morning, everyone. Thank you. My name is Jez Humble. I work for Google, and I'm going to talk about whether DevOps is still relevant in a cloud-native world. Obviously, the answer to that question is yes, so relieve the suspense straight away so no one's on the edge of their chairs. I'm going to mainly talk about enterprise situations, so big companies, lots of different projects, that kind of scenario. If that's not what interests you, there's like 6 other sessions going on now, and I won't be at all offended if you're like, okay, this is not for me, and head off. That's absolutely the right thing to do. This was kind of kicked off because I read this blog post from Devopsdays Portland earlier this year, where Graham King on his blog says, DevOps is ops with new tools. I went to DevOps Days thinking DevOps means developers and operations merged into one team. I was wrong. I did not meet or hear from any developers. It was a gathering of systems administrators who use version control and write a lot of YAML. Programming languages were not a topic. I heard Python mentioned once in passing, that's it. DevOps means the veteran admins had to check in their personal scripts and everyone is expected to automate more things. They relate to the software their business runs, the way the merchant navy captain relates to what's in the containers on his or her ship. So I kind of did that a bit. That's not quite right. There is something to this, and I want to try and unpack some of this over the course of the next 30 minutes or so. So I'm going to start with DevOps. I think the best way to think about DevOps is as a movement that's trying to solve certain problems. So when I talk about the DevOps movement, it's a community of practice. And as a community, we're trying to solve a problem. How do we build, evolve, and operate distributed systems at scale? So distributed systems, anytime we're talking about how to get better at building distributed systems, we're basically talking about DevOps. Anytime we're talking about making them more secure, more resilient, how to change them at scale, we're talking about DevOps. DevOps famously doesn't have a definition. I don't think this is a problem. There's lots of definitions. The one we have on the site we just put up, cloud.google.com/DevOps, is this: an organizational cultural movement that aims to increase software delivery velocity, improve service reliability, and build shared ownership among software stakeholders, which is as good as any. I think crucially, it's about ownership of outcomes. What are the outcomes we're trying to create? So, as some of you will know, I've been working for the last 6 years on the State of DevOps report, which is a very big research program looking into how to build high-performing teams and organizations. And we found a valid and reliable way to measure software delivery performance. So that's an outcome that hopefully we all care about. So how do we measure this? There's 4 key metrics for software delivery performance, which is all the ones that aren't gray. There's 2 measures of throughput, lead time and deploy frequency. So lead time is time from check-in to code in production for any given change. Deployment frequency, obviously how frequently you deploy to production. And then 2 measures of stability. Change fail rate, when you push a change into prod, what percentage of the time do you have to remediate in some way, and then time to restore. When there is an incident in production, how long does it take you to restore? Last year, we added a new one, availability, and what we find is that availability is also important, and these things together form something that moves all together. And what I mean by that is when we look at all the people who we gather data on, what we find is that high performers are not making trade-offs among these different objectives. And if you take one thing away from this morning, it should be this: high performers are not making trade-offs among these objectives. High performers do better at stability and throughput and availability. So just to put some numbers on that, these are the results from this year. What we find is that there's an elite performing group who's deploying multiple times per day, takes them less than a day to get changes live. They restore service in the event of an incident in less than an hour, and their change fail rate is really low. right on the other end, there's low performers who are releasing between once a month and once every 6 months. It takes them about the same amount of time to get changes live because they batch up changes into big releases. It takes them a really long time to restore service, and like a shockingly long time, between a week and a month. And you know, that's partly the granularity of the way we ask the questions. We ask, you know, less than an hour to a day to a week to a month to several months. So partly it's the granularity. But that was really shocking. And what we think is going on is that a lot of incidents take a long time to fully remediate. Like if you have a security breach, it might take you a really long time to actually fix all. You might be able to get the system up and running, but it might take weeks potentially to find all the little problems and remediate everything and do data fixes and so on. And they have this relatively high change fail rate. Every year that we've done this analysis, the clusters have fallen out this way. There's a group that's doing really well, a group that's doing really badly, and one or two groups in the middle that are kind of doing okay. So, as an industry, we're not trading off speed against stability. The practices that enable high performance enable you to achieve higher levels of throughput and higher levels of stability and availability too. Obviously, if you're on the low end, you want to know how to get better. And so we've been studying all the different capabilities that impact high performance in our research program. This is what we lovingly call the BFD, or the big and fulsome diagram. And I'm not going to go through this now, because it's a lot of different stuff. But you can, I think, Google Nicole FV, BFD. These slides will be available. So you can look at the slides later if you're interested. But broadly speaking, software delivery performance is that kind of box towards the right, SDO performance with a couple of other boxes in it. And there's broadly 4 classes of things that point to it. On the bottom left is a set of technical practices. Above that is a set of kind of management and product development practices. Right on the top is a bunch of cultural stuff. And then on the far left is effective transformational leadership, which is what enables you to implement the practices, and the practices are what drive high levels of performance. So in particular, the technical practices are what we call continuous delivery. And over the years, continuous delivery has turned out to be a lot of stuff. And you can see some of it here. There's everything from trunk-based development, continuous integration, through to testing practices, through to database practices, and then building security in, and even stuff like loosely coupled architecture, how you architect your systems. All this stuff together makes up continuous delivery, a lot of different practices, and those practices drive software delivery performance. They also result in lower levels of burnout on your teams. They result in lower deployment pain, and they result in higher quality measured in terms of the amount of rework you do. So not only do they make you better at software delivery, they make your teams happier as well, and they drive culture. One of the themes this morning is going to be building continuous delivery into everything. We also wanted to look at cloud practices. So last year, we looked at how to effectively deploy cloud practices. Who here is running their software in the cloud? All right. Great. Lots of you. That's probably why you're here. So NIST, the US government's National Institute of Standards and Technology, has a very small paper which defines cloud in terms of 5 capabilities. And we asked people the extent to which they were implementing these 5 capabilities. So quick test. Put your hands up if you're using cloud again, and keep them up. So if you cannot self-service the resources you need on demand through an API, put your hands down. So if you have to send an email or create a ticket in ServiceNow in order to get a server or change the config of a server or something, put your hands down. If you can just run a command, go through an API, you can keep your hands up. All right, broad network access. If you can't access your cloud resources on any device you want, put your hands down. Otherwise, keep them up. Okay, now the next three are relatively easy. Resource pooling, if you're using virtualization, that means there's more virtual resources running on a smaller number of physical resources. Hopefully that's true for everyone. Rapid elasticity is the illusion of infinite resources. So you can scale up and scale down. That happens automatically on demand. Yes. And then measured service, you only pay for what you use. Okay, good. So like a little over half of you who had your hands originally up still had them up at the end. So that's great. What we find is that of people who said they were using the cloud, only 29% in the survey actually met all 5 of those characteristics. So this audience is actually doing pretty well compared to our wider range of survey responses. But this is really common. Organizations say, we're going to implement an enterprise cloud. And developers, at the end, still have to raise a ticket in ServiceNow to get a VM. Or they still have to send an email to get a VM or change a network setting. So the outcomes for developers haven't changed at all. They're exactly the same. And my point is, if you're doing that, you haven't built a cloud at all. And it's not just me saying that. It's the US government, and that used to have more credibility than it does now as a claim, but you know. If you are doing all those 5 things, you're 24 times more likely to be in the elite performing group. Now that's a correlation. That's not a prediction in the same way that there's predictions in the BFD, but that's a pretty big number. And we also know that implementing these practices does predict software delivery performance. So it does drive software delivery performance. So in the rest of the time, I'm going to talk about 2 things. Firstly, how you build cloud platforms, and secondly, how you should build the apps that sit on those platforms. So let's talk a bit about platforms. The problem with cloud platforms, or the reason why you would care about cloud platforms, is because if you work in the enterprise, you probably have this problem. You have probably hundreds or thousands of services running in production. So who here, quick pop quiz, who here is working in a company of 1,000 people or more? Okay, quite a lot of you, maybe 2/3 of you. 10,000 people or more? Still quite a lot of you, wow. 100,000 people or more? Wow, maybe like 1/3 of you. 1 million or more? Okay, 1 person up there. Is that Indian Railways or the People's Liberation Army? Okay, he's just gone onto his phone. Okay, I won't ask that question. Who's running more than 1,000 services in production? Yeah, probably like 25% of you. Who's running more than 100 services in production? Okay, maybe 2/3 of you. Okay, so that's really painful. Who has services that are in more than 5 languages? Okay, like probably about 1/2 of you. So that's really painful. And research by the Forresters and Gartners of this world find that about 70% of the IT budget is spent on just keeping the lights on and adding capacity to those services, just because maintaining them is so much work. And now we're supposed to be doing all this stuff I just talked about, CI, CD, blah, blah, blah. And the problem is, most people aren't really into doing that maintenance stuff. As Kurt Vonnegut says, another flaw in the human character is that everyone wants to build and no one wants to do maintenance. And you know, that's ops work. That's what ops people do. They're like, you know, I'm that person. I like everything to be tidy and clean, and I like to delete things. That's my favorite thing to do. I like deleting things, so ops is perfect for me. I spent a year working for the US federal government in a team called 18F. 18F was one of the teams that was created as part of the Obama tech surge, which happened when healthcare.gov went horribly wrong, and they suddenly realized they need people who are experts in technology working in the federal government to try and sort out all the problems they had from contracting everything out to big teams of contractors who didn't work together well. One of the things that we found is that it took a really long time to get systems live in the US federal government. Once you were dev complete, it could take about on average 6 to 9 months to go from dev complete to live. And it was an extremely complex process. You have to document all the information security controls you need to implement. You need to test those controls. You need to document the testing of the controls. You put a huge documentation pack together that has to be approved by loads of people, and it takes months. So we thought there must be a way to make this simpler. And when I arrived in the 18F team, they'd already started work on this thing called cloud.gov. One of the cool things was that we got the domain cloud.gov. That was pretty awesome. And what cloud.gov is a platform as a service which took care of most of the information security controls at the platform layer. So if you deployed your app onto cloud.gov, you didn't have to worry about implementing a big subset of those controls, and it made it much quicker to go through the approval process. Another reason that we built cloud.gov is that when 18F started, we just created an Amazon account and gave all the developers administrative access to the Amazon account, and we were like, just go nuts, off you go. Which, sounds like quite a DevOps thing to do. So I joined about a year into this, and my boss said, okay, you're in charge of the AWS accounts now. And I'm like, okay. So I log into the AWS console, and I start looking around, and basically I'm just really horrified, spitting out my tea. There's so much crap in there, and I have no idea what any of it does, who created it, who it belongs to, and crucially, because I love deleting things, what can I actually delete? Can I delete this load balancer? Who knows? What network traffic's running through that? What service is it associated with? No one has any idea. So you basically start doing archaeology. And most of my year in government was doing archaeology on this account so that I could delete it, so that I could not be really anxious all the time. So like anxiety-driven ops, which is the best ops. So in the course of, and so this was a major motivation for moving everyone to cloud.gov, was just making it so we could actually manage this stuff and not just be overwhelmed by complexity and brittleness and getting alerted in the middle of the night. So all these lessons are learned from this experience, basically. So if you're designing a platform as a service for the enterprise, these are the things that I think you should care about. So number one is garbage collection. There's a whole bunch of stuff sitting in my cloud. Who's paying for it? Who should I be billing for it? In the government, this is really important because in the government, you're only allowed to spend money that's been appropriated by Congress. If you spend money that's not in your budget, you have to write a letter to the president, which again used to be something that people cared about and was bad. Now, sure, I'll write a letter to the president. But at the time, it was considered quite a bad thing. So you have to be really careful about spending money. You can't spend money that's not in your budget. So being able to bill stuff to the agencies who are actually using it is super important. And then crucially, if you're like me, you just want to delete everything. So what would happen if I deleted this? Is anybody even using it? There's traffic running through it. But does that mean someone's using it? Or is it just like zombie traffic from some load that someone put in some test environment? Number two, you want to make changes. And this happened quite a lot. We'd build stuff, and then it would sit in production. And in 18F, you have a 2-year service, and then you go off and do something else. So by the time I started at 18F, there were services built, and all the people who had worked on that service had left. And now we need to make a change to that service. Where's the source code? How do I deploy it? These are all important questions that you need to be able to answer. Multi-tenancy. You want developers to be able to self-service stuff. Otherwise, it's not a cloud. But how do you make it so that when they do that, they can't possibly impact other services? Or if I delete this service, it's not going to have knock-on effects on other services. So being able to have nice, safe boundaries around all your infrastructure so people can't hurt other people's stuff and we can delete things safely, super important. And then finally, just all that complexity. How can we even make sure we can hire people who know how to work on this, for example? And crucially, how can we make sure that all that stuff is up to date? So going back to those first principles, lead time is really important. How long would it take your organization to deploy a change that involves just one single line of code? Do you do this on a repeatable, reliable basis? This is the kind of null deployment lead time that Mary and Tom Poppendick talk about in their book, Lean Software Development. This is really important in a modern InfoSec environment where we have advanced persistent threats and there's just always people trying to hack into our services. Because when there's a vulnerability, there's this really important question you've got to ask, which is how long would it take you to find, patch, and redeploy all the applications that are impacted by a vulnerability? And the answer really should be of the order of hours, and definitely not more than days. There's a talk going on, I think right now, which talks about Apache struts and the Equifax breach that happened last year. I think it was last year. Time flies. No, 2 years ago. Good grief. And what happened was Equifax was hacked and everyone's data was stolen, not because someone was deliberately targeting Equifax, but because someone who was just testing the internet for servers vulnerable to this exploit happened to get into Equifax systems and start rummaging around and be like, oh, I'm in Equifax, sweet, let's steal all the data. And that was because there was a flaw in Apache struts that was unpatched for several months after that vulnerability was disclosed. So in an enterprise context, being able to answer this question is really important. When a vulnerability comes out, how can I find all the impacted systems and patch them as quickly as possible? And solving that problem is going to involve fixing all those other things I've talked about. So this is a really great question to focus on as a driver for building effective platforms as a service. Because if you can answer this question, you're going to solve a whole bunch of other stuff as well. I think the most important principle for platforms as a service is a really hard separation between the platform layer and the app layer, number one. And secondly, making the app part of that stack as small as you possibly can. Like have as much of the stuff happening in the platform part of the stack as you possibly can, and as little in the app part as you possibly can. And what that means in particular, so cloud.gov was implemented using Cloud Foundry, open source Cloud Foundry sitting on Amazon. And Cloud Foundry has this concept of build packs. It's like Heroku, where you have these pre-built images for Java or for PHP or for Python or whatever, and developers don't get to choose what's in that stack. Here's your stack, you deploy your app on top of that, you don't get to customize that very much. And developers don't like that very much, but it's really, really important from an InfoSec point of view. For example, while I was there, we had this situation where a vulnerability was discovered in the Java stack. We were able to patch the whole production environment in less than 24 hours. All those different apps, because we just got the upstream build pack, applied the patch to that, and then in Cloud Foundry, you can just redeploy that build pack to the whole environment without the app developers even knowing about it. It's super simple. So that, for me, is the reason to make the app bit as thin as possible, is because then, as an application developer, I don't have to worry about all the vulnerabilities hitting my stack, and I'm not responsible for fixing them when they happen. That doesn't, I don't know, maybe it doesn't sound like a big deal to you, but it's a huge deal. Being able to keep all your stacks up to date so that you have to patch as infrequently as possible to keep your application up to date. So what this means is you have a platform team, which is a cross-functional team of developers and ops people who are responsible for building the platform as a service. And that's treated as a product in its own right, where the customers are your development teams. You want to take as much of the application stack away from the developers as possible. And then there should be a self-service API for deployment so that developers can deploy their own stuff, and so that CI, and developers shouldn't be deploying to production, that should always be done through CI. But again, you give credentials to CI so that CI can deploy to production, and that can be done in a fully automated way. By using this model, what this meant is, for cloud.gov, in the federal government, if you deploy a moderate impact information system, there's 325 information security controls that you have to document and test. We took care of 269 of those controls at the platform layer. And if you're an app developer, you only had to care about between 15 and 46 controls. That made it much quicker and easier to deploy your app, and it made your apps much, much safer. Things like virus scanning, vulnerability detection, penetration tests, those were all taken care of at the platform layer in a fully automated basis. And we were using continuous delivery to deploy the platform as a service from Git in a fully self-service automated fashion. So we were using all these same principles of continuous delivery to build and deploy our platform. So what that means is, going back to those 4 things I talked about earlier, the platform should make sure that every virtual resource is assigned either to an app or the platform. And both Cloud Foundry and Kubernetes has this concept of resources like databases that you can assign to an app, and when the app gets killed, the database instances and any other associated infrastructure gets killed as well. You want to make sure that it's possible to redeploy any app at the click of a button. That's crucial, so that if there are vulnerabilities in the app, you can just check the new version of the library that app uses into version control, and then deploy that in a fully automated fashion through your CI system. Multi-tenancy has to be something you think of from the beginning. So either use something like Cloud Foundry. One of the things that I discovered moving to Google is that Google Cloud Platform has a really nice story around this. Google Cloud Platform has this concept of projects, which make it much easier to do multi-tenancy. So, you know, I'm not here to talk about how great Google Cloud is, but that's one thing that I found really nice about Google Cloud. And then finally, to make sure you can manage complexity and that you don't just die under the weight of maintaining this stuff, you need to reduce options for application developers. So predefined runtime stacks that the platform operators can patch and redeploy on demand. That's super important. All right, I'm going to switch gears and talk about the apps. So one of the other things that we researched is, you know, what architectural practices are important. And what we found was quite interesting. When people think about architecture, they usually think about, you know, Kubernetes and microservices and all this kind of stuff. We found that stuff is not so important. What's important is the outcomes they enable. And these 5 things were highly predictive of your ability to implement continuous delivery. Number 1, can my team make large-scale changes to the design of its system without the permission of someone outside the team or depending on other teams? Number 2, can my team complete its work without needing fine-grained communication and coordination with people outside the team? Number 3, can we deploy and release our product or service on demand independently of other services the product or service depends on? 4, can we do most of our testing on demand without requiring an integrated testing environment, like a staging environment which has all the other apps deployed in it? And 5, and this is really kind of the litmus test for are you doing continuous delivery, can we perform deployments during normal business hours with negligible downtime? And if you answered yes to all these questions, that was highly predictive of your ability to do continuous delivery, which in turn is highly predictive of your ability to achieve speed and stability, those software delivery productivity metrics I talked about at the beginning. So here's the thing. You can do this with mainframes. You can also implement the latest WYSI Kubernetes microservices architecture and not achieve this, in which case you wasted all your money. It's the outcomes that are important, not the technology that you use to achieve those outcomes. Now, you know, I think Kubernetes is great. You know, I think all these tools are amazing. But I remember doing all this stuff with bash scripts and CVS. So I know that you don't need this stuff. It definitely makes it a lot easier if you do it right. But a lot of people lose sight of the outcomes that it enables because they're having too much fun focusing on getting down in the weeds. And it's important to remember the outcomes. There's an architecture that I think is kind of quite nice for achieving some of these goals. And there's a talk on this tomorrow, I think, which I'm quite excited to see. But it's something I only came across this year and I've been playing with and I quite like. Who's heard of the Jam stack? Okay, not many of you. Cool. So Jam stands for JavaScript, APIs, and markup. And the idea is this. Your basic static site is deployed into a bucket, a static storage bucket in the cloud with TLS termination in front of it, like CloudFront or some kind of TLS termination, content delivery network type thing. And then all your static content is served and your main website just out of a static bucket. And then the JavaScript in that static bucket calls to cloud functions as a service, in order to do any kind of business logic-y stuff, and that in turn talks to persistence where necessary. And so you can independently deploy all those functions, and then you can independently deploy your kind of static stuff to a bucket sitting in the cloud. So I really like this. First of all, it's super cheap and very, very scalable, because most of your content is being served from a CDN, which in turn is being served out of a bucket in the cloud. So super, super cheap, scales incredibly well. And it also makes the attack surface area really small. Like, you cannot hack a bucket sitting in the cloud. I mean, there's nothing to get into, as it were. It also has a nice separation of concerns between the content. So you can have your content people checking in changes to HTML, CSS, JavaScript, and deploy that independently of the code which the functions are running off. So it's got this nice separation of concerns where your content team can work on their stuff without touching the functions that are doing all the back-end stuff. Really easy to configure and deploy. Relatively easy to develop and test. So I think this is kind of cool, and I've been playing with it and I kind of liked it. So definitely not the only way to do it, but definitely something that I think is worth looking at. It does have some disadvantages. You don't get to put Kubernetes on your CV, so that can be a bummer for developers. You have to think a lot about service boundaries and dependencies. I think you kind of have to do that anyway, I'm going to argue. And you have to rely on your platform for things like canary releases and auto-scale and cold start and things like that. But again, I think actually putting all that stuff in the platform significantly reduces the complexity of what you're building, and that's a really good thing. The more you can rely on the platform primitives to take care of all this stuff, the better. A lot of people don't like that. They think it's, well, then we're locked into the vendor. I really don't think, I've done stuff on Amazon, I've done stuff on Google Cloud. I just don't see the big deal about vendor lock-in. The complexity that you introduce by trying to make things platform agnostic, I think is just so much more expensive than anything that you could gain by moving between vendors. I just don't think that trade-off is worth it in most cases. So the more stuff you can rely on the platform for, the less stuff you're going to have to maintain. I mean, anyone who's like running their own custom database on the cloud, I think that's crazy. Just use like whatever the database provided by the platform is. Then you don't have to upgrade it. You don't have to maintain all those settings. Like, let the platform take all that stuff away from you. A lot of federal agencies, they won't use security groups in Amazon. They're like, we're deploying our own network appliances. It's madness. Like, don't do that. Just use the cloud primitives. So the more you can lean on the cloud primitives, the better, I think, because it substantially reduces complexity. Okay. So to conclude, a lot of people think that cloud native is about installing Kubernetes and start deploying apps and yay. I'm going to say, don't do that. I mean, install Kubernetes by all means, but as part of a platform strategy that includes a platform that can take care of not just deploying your apps, but all the services that your apps depend on, being able to manage those, being able to manage monitoring and alerting, and all these other platform level things. That needs to be a fully managed product that is accessible through an API, that developers can self-service what they need, and that developers have to not worry at all about being able to collect and aggregate logs and get notifications. That should all be handled by the platform. Take as much care of as much as possible at the platform layer and give developers a beautiful small little box that just does all the stuff they want, and don't let them customize it. You've got to architect for this stuff, both at the platform layer and at the app layer. There's a whole bunch of technical skills and processes that are necessary to implement continuous delivery. You've got to develop all those skills. You're not going to be able to hire those people. You've got to develop it inside your organization. You have to develop capacity. You have to provide resources. And you have to create a culture of continuous improvement. I've got another talk this afternoon. If you're interested in building high-performing teams, I'll be talking about that part of it this afternoon. That's critical as well. OK, that's it. Questions? Oh, thank you very much.